Okay, so now let's use what we identified in question 1, namely if I want to find a general solution to a non-homogeneous differential equation, such as the equation in 2, we can first find the homogeneous solution. So to do so, we would set up our characteristic equation, r squared minus r minus 12 is equal to 0. And this we can factor into r minus 4, r plus 3. So we get two roots, two distinct real roots, namely r is equal to 4 and r is equal to minus 3. And this gives us our homogeneous solution, which would be c1 e to the 4t plus c2 e to the minus 3t based on those two roots. Great. In part B, now we want to find a particular solution to this non-homogeneous piece. So our initial guess for this probably would be something that resembles the function, the forcing function. So if our forcing function is e to the 4t, then it would make sense to try and guess a times e to the 4t. But let's look at this and compare it to what we just found in the homogeneous solution, that here we can see that a e to the 4t would actually be a homogeneous solution. So when I plug that in, I'm going to get 0. So the way that we fix the situation with resonance is we introduce extra multiple t in here. So my guess is going to be a t e to the 4t. So I've got that extra t in there. And now if I want to plug this into the differential equation, well, first I would find the derivative, and to do so I would use the product rule. So I would say a times the derivative of t, which is 1, times e to the 4t, plus the derivative of e to the 4t, which is 4e to the 4t, times a to the t. So in other words, I get 4at e to the 4t. And then I'm going to go ahead and calculate the second derivative of x of p. So over here, I would get a 4 that comes down, a e to the 4t. And then I would use the product rule again on this piece when I find the second derivative. And so that would give me 4a e to the 4t plus 16 at e to the 4t. Now I'm going to plug x of p, x prime of p, x double prime of p into the original differential equation. So for the second derivative, I can combine the 4a terms and get 8a e to the 4t plus 16 at e to the 4t. And then I'm going to get minus xp prime, which is a e to the 4t plus 4a t e to the 4t. And then we're going to subtract 12 times x of p, which we started with a of t e to the 4t. And so let's first take a look at all of the terms that have this extra t in it. And what you can see is these would all cancel out. So I have positive 16 over here. I've got minus 4, another minus 12. So I get positive 16 and a minus 16. So those all cancel out. I'm just going to cross those off. And what's left over now is just this term minus this term. So in other words, what I have left is 7a e to the 4t. And in order for this to be a solution, recall we want to get the forcing function, which was e to the 4t. So this tells me that 7a is equal to 1, or in other words, a is equal to 1/7. So now I've got my particular solution namely x of p is going to equal 1/7 times t e to the 4t. And to put all of this together, our general solution we can write as the homogeneous piece plus the particular piece. And so for the homogeneous piece, we had C1 e to the 4t plus C2 e to the minus 3t. And now we can add on to that the particular solution, which was 1/7 t e to the 4t. And so if I were to plug this solution back up into the original differential equation up here, then plugging in this piece would give me 0. Plugging in this piece gives me the e to the 4t that I wanted. So I would indeed get a solution, since we would get e to the 4t on the right-hand side.